Okay, in this video, I'm going to talk about the content from Unit 3, Activity 6, which is all about first differences and rates of change. So I've got two table of values here that we're going to kind of dissect and talk about. First of all, to calculate first differences. First differences is just another way of saying how much does our y variable or our dependent variable change each time we change x. So the way I calculate first differences is I just subtract the value above from the value below. So another way of saying it is just how much is y going up by. So 18 minus 13 is 5. Going to eyeball a lot of these. 23 minus 18 is 5. 5 and 5. So because I'm going up by 5 each time, my first differences are all going to be positive 5. And if you can think about drawing a graph, if I'm going up by the same increment each time, then it must be a straight line. So if my first differences are equal, we have a linear relation or a straight line. If they're not equal, then it's not a straight line. It might be some type of curve, or it might just be some sort of zigzag. But if they're equal, then it's a straight line. Another term or another way we can write first differences is that's the change in y. So delta is the fourth letter of the Greek alphabet. This is a capital delta. And delta in math and also in physics just means change in. So first differences is a way of saying change in y, or change in the dependent variable. The second related concept is what we call a rate of change. So a rate of change is asking how much is y changing for every unit that I change x by. So how much is my dependent variable changing when I change my independent variable? So in this question, because x is just going up by 1, then sure enough, my rate of change is the same as my first differences. The rate of change is just 5. Here's an example where the first differences and the rate of change are not equal. I think I've actually made a mistake in making this table. So let me redraft this. I think my first differences weren't equal there. So these might be numbers that we see in a word problem. So the numbers are a little bit bigger. They're all positive. So this might be a question with time and distance in kilometers. Maybe it's a helicopter flying. So we could think the x column is time in minutes, and maybe the y column is kilometers. I think that'd be a pretty fast helicopter. Maybe someone else can look up how far helicopters travel. And I can calculate my first differences the same way. I'm subtracting the value above it in my dependent variable. So 345 minus 300. So I've got a first difference of positive 45. And each time, we can verify that it's a linear relation because my first differences are equal. But this doesn't mean that my rate of change is 45, because my increment, now my x's are going up by the same time, but they're not going up by 1. I can do the same thing. I could subtract 30 minus 20, so my x's are always changing by 10. So when we think about calculating rate of change, we can define rate of change as what's the change in my dependent variable divided by my change in the independent variable. So what we're really asking is how much is y changing for a 1 unit change in x? So I'm dividing, in this case, 45 by 10. So my rate of change is 4.5. So maybe the helicopter or the airplane or the fighter jet is flying 4.5 kilometers per minute. So that's what rate of change is. I'm taking my first differences, my change in y, and now dividing it by my changes in x. We're going to have a lot of different terms for that throughout this course. So we're calling that today rate of change, or delta y over delta x. But in the next unit, we're going to start referring to this as slope, which is another way of saying how steep or how shallow is our line. So to calculate first differences, we're just subtracting our y value from the one above it. And then rate of change, I'm doing my delta y divided by my delta x. So that should be enough to get you finished your Unit 2 Activity 6 assignment, which you can hand in whenever you're ready. And please send me an email if you've got any questions.